So this is the circuit I designed for the temperature sensor project in Multisim. And this is that same circuit over here on the breadboard. If we take a look back here for a moment just to analyze it, to begin with, we have an adjustable voltage source. And what this is simulating a voltage dependent on temperature. And the way we're doing that, we can see here, is through a voltage divider. So as this resistance changes, which this is the thermistor, the reference voltage will change as well. So this voltage is dependent on temperature, right? So if we go back here, that voltage, which this would be that voltage, the reference, is fed into this, and what this is called is a window comparator. And what it does is compares the input voltage to two thresholds, an upper and a lower. So we have boundaries, and the idea of this was that we could figure out through our voltage divider, and then this table, which lists the thermistor resistance at different values, we could figure out what the voltage would be at negative 20 degrees Celsius and 10 degrees Celsius. So that's what I did, and then I set those voltages through once again a voltage divider to set a reference voltage for the comparator for each of these. So we have 2 volts and 0.75 volts, right? So that gets fed into here, it compares them, and then it outputs into the ADC, which is read out by these LEDs. So right now at 1.25 volts, where we are within our boundaries, right? So we essentially have nothing being output. This will be blocked by the diodes, and as we can see, we have 0 volts. So at 0 volts, all the LEDs are on, which is what we want. So if we go back over here, and let's kick this up to say 2.5 volts. So now this comparator should be kicked on to the high state, and as we can see, it is. And then we have a voltage here. There's a little bit being ate up by the diode, and as we can see, the state of the ADC has changed. So the idea behind this was that as long as we're within our boundaries, the 2 to 0.75 volts, all the LEDs will be on because we'll have 0 volts here. And that's how we know that the temperature is fine, we're in a normal state, and there's nothing to be worried about. But if the temperature goes outside of that, these LEDs will change, and that's sort of arbitrary because all we're worried about is whether or not they're all on. If there's any other state, that's what indicates that there's a problem that needs to be addressed. The one other thing we have here that we need to discuss is this test circuit. This is basically just to verify the circuit's operation. So to test that, we'll just put it back into its normal state. Sometimes when you change the voltage too fast, it doesn't like it. So we'll just start the simulation again. All right, whoops. So now we're back within our boundaries. All our LEDs are on, good. So if we just flip this switch, now we can see that we have 5 volts here. So the point of the switch was just that it feeds 5 volts in to test to make sure the state will change, and it did. That's what we want. So I'm gonna make another video of testing the breadboard circuit here, and yeah, so that'll be in another video.